Something is leaking out of Jupiter's core, and scientists genuinely have no idea why. This isn't a clickbait headline. This is a real discovery that is forcing researchers to completely rethink what we thought we knew about the largest planet in our solar system. And the deeper you go into this story, the stranger it gets. Let's start with what we actually know about Jupiter, because understanding the mystery requires understanding the planet first. Jupiter is enormous in a way that is genuinely difficult to process. You could fit over 1/300 Earths inside it. It has no solid surface. It is essentially a swirling, violent ball of gas and liquid that gets denser and hotter the further you descend into it. At its center sits a core that scientists have debated for decades. Is it solid? Is it liquid? Is it something in between? That debate has never been fully settled, and now we have a new layer of confusion added on top of it. Here is where things start to get truly fascinating. For a long time, the prevailing model of Jupiter's interior suggested a clean separation. You would have the outer layers of molecular hydrogen, then metallic hydrogen deeper down, and then a compact, distinct core of heavier elements right at the center. Neat. Organized. Understandable. The problem is that Jupiter did not get the memo because that is not what the data is showing us. Scientists analyzing data from NASA's Juno spacecraft have found evidence that material from Jupiter's core appears to be mixing upward into the surrounding layers, not staying neatly contained, not behaving like a well-defined solid ball sitting at the bottom of the planet. Instead, heavy elements that should theoretically be locked deep inside are showing up where they have no business being. And the question that nobody can fully answer yet is how and why this is happening. The Juno mission has been nothing short of revolutionary. Launched in 2011 and arriving at Jupiter in 2016, Juno has been orbiting the planet and measuring its gravitational field with extraordinary precision. Now here is why that matters. A planet's gravitational field is not perfectly uniform. It has variations based on how mass is distributed inside. By mapping these variations in incredible detail, scientists can essentially work backward and figure out what the interior of the planet looks like without ever being able to go there. And what Juno's measurements revealed stunned the scientific community. The data pointed toward something called a dilute core, or what some researchers describe as a fuzzy core. Rather than a sharp boundary between the core and the rest of the planet, there appears to be a gradual blending. The heavy elements at the center seem to be dispersed outward across a region that could span tens of thousands of kilometers. That is not a small rounding error. That is a fundamentally different picture of what this planet looks like on the inside. So what could cause this? This is where the science gets genuinely speculative, but in the best possible way, because even the speculation is grounded in real physics. One leading theory involves giant impacts early in Jupiter's history. In the chaotic early days of our solar system, massive planetary bodies were colliding constantly. The thinking goes that Jupiter may have been struck by another planet-sized object or multiple objects with enough force to partially disrupt and mix its core. That ancient collision, billions of years ago, could still be playing out in slow motion today as the planet gradually tries to settle back into equilibrium. But here is what makes this even more mind-bending. Settling back into equilibrium might take billions more years. We could be witnessing the aftermath of an ancient cosmic catastrophe that is still unfolding in geological slow motion. The mixing we are detecting might be the echo of an impact that happened when our solar system was still young. That idea alone should stop you in your tracks. There is another theory that does not require a dramatic ancient collision. Some researchers think that the mixing could be driven by something called semi-convection, or double diffusive convection. These are processes where temperature and composition gradients interact in complex ways to drive material upward even when normal convection would be suppressed. In other words, the physics of Jupiter's interior might naturally produce a situation where heavy elements gradually migrate outward over billions of years without any catastrophic event triggering it. It could simply be how the planet works. And here is the uncomfortable truth that scientists will freely admit. They are not sure which explanation is correct. Both are plausible. Both fit within our current understanding of physics. and both have radically different implications for how we understand planetary formation, not just here in our solar system, but across the entire galaxy. Because this matters way beyond Jupiter. Astronomers have now cataloged thousands of exoplanets, many of them classified as gas giants similar to Jupiter. Our models for how those planets form and evolve are built on assumptions about planetary interiors. If Jupiter's interior does not match our best models, then our models are wrong. And if our models are wrong for Jupiter, the planet sitting right here in our own solar system that we have been studying for centuries, then how confident can we really be about our predictions for planets orbiting distant stars? This is the ripple effect of one discovery. It starts with a strange gravitational reading from a spacecraft orbiting a planet, and it ends with questions about whether we understand planetary science at all. Not in a catastrophic way, but in the exciting way that science works when it is functioning at its best. The data surprises you. You go back to the drawing board, you build better models, and in the process, you inch closer to real understanding. What we also cannot overlook is the sheer scale of what might be happening inside Jupiter right now. If heavy elements are genuinely migrating outward from the core, they are doing so through layers of metallic hydrogen. This is a state of matter that does not exist naturally anywhere on Earth. Under the crushing pressures deep inside Jupiter, hydrogen behaves like a liquid metal, conducting electricity and generating the most powerful magnetic field of any planet in our solar system. The interaction between migrating core material and this metallic hydrogen layer could be influencing Jupiter's magnetic field in ways we are only beginning to understand. Juno has also detected unexpected asymmetries in Jupiter's magnetic field, and some researchers wonder whether the fuzzy, leaking core could be connected to those anomalies. The magnetic field is not perfectly symmetrical the way you might expect from a simple planetary model. It has patches of stronger and weaker field strength. It behaves in ways that suggest the interior is more complicated than our textbooks suggested. Could the migration of core material be partly responsible? Nobody knows yet, but the question is on the table. What this story ultimately teaches us is something profound about the nature of scientific discovery. We sent a spacecraft to Jupiter specifically to answer questions about its interior, and it answered some of them while opening up an entirely new category of questions we did not even know to ask. That is not a failure. That is science doing exactly what it should do. Jupiter has been in our sky since before humans existed. Ancient civilizations tracked its movement. Galileo pointed his telescope at it and changed our understanding of the cosmos. Spacecraft have been studying it for decades. And yet, right now, in 2026, there is something leaking out of its core that we cannot fully explain. The largest planet in our solar system is still hiding secrets from us. That is not a reason to feel unsettled. That is a reason to feel alive with curiosity. Because every mystery like this one is an invitation. An invitation to look deeper, think harder, and ask better questions. Jupiter has been speaking to us for centuries. We are finally starting to learn how to listen. And what it is telling us suggests the universe is far stranger and far more wonderful than we ever imagined. The core of the largest world in our solar system is not sealed shut. Something is getting out, and we are only just beginning to understand what that means. Subscribe to stay updated with powerful insights about the planets and hidden secrets of our solar system.